All right, away we go with day 57, folks. This is going to be a bit of a strange day because it's an investigation day. It's a discovery day after the 3-minute review. So let's take up the 3-minute review and we'll chat about what the rest of the day will bring. Last day's goal is to evaluate expressions involving exponents. Big, long, nasty expression, but um, we're not going to substitute and use our calculator right away. We're going to do some exponent stuff, right? So let's do some exponent stuff. You see here that this 3 acts on everything inside the brackets. So this is z squared also cubed. And on the bottom, I'm just going to write this down for now. This part, oops, that part right there, don't worry about that part. That was just me goofing up. That part there is a number. I'm going to evaluate that. That's 8, and I'm going to write it out front. Okay? And then the second part of this next step is, well, I see I've got some exponent laws to work on. And I got some z's there, some y's there. Well, let's subtract the exponents because um, I'm dividing powers with the same base. 3 subtract -1. Be careful with your integers there. That's the same as adding 1, right? Subtracting a negative is the same as adding. So that's x to the exponent 4. And then y, 5 subtract 9 is -y to the exponent -4, I think. Oh, that's, yeah, sorry, y subtract 4. I thought that was a 9. Couldn't read my own writing there. 4. 5 subtract 4 is just 1, eh? Easy peasy, just 1. And then here, I did that. That's taken care of. Did that. This is z to the exponent 6. And then on the bottom, I've taken care of that. I've taken care of that. The z to the exponent 6 is going to cancel, right? I got this z to the exponent 6 because I got exponents on exponents. 2 times 3 is 6, and then I can cancel those. Those are exactly the same. I can't simplify that expression anymore, so I'm going to go over here and evaluate it. Notice, until this point, I haven't needed my calculator, so that's good. I'm going fast. Y to the exponent 1. -1 to the exponent 4 is just 1. And so what do I got? I got 40. That's it. That whole thing, this whole mess with 11.3s and 5s and exponents and all this stuff simplified down to 40, and in not very much work as long as we knew to simplify first. Simplify first. Okay, the next couple of pieces are leading into today's stuff. Give 2 or 3 numbers that are easy to take the cube root of. It's the idea of cube root of something here where the answer is something nice. Remember, a cube root is something where a number times itself 3 times is equal to this one in here. So if these are something small, then it would be a number that's easy to take the cube root of. So 8 is easy to take the cube root of. The cube root of 8 is 2. 3 would be 27, right? So the cube root of 27 is easy to take. And then so on. They get big fast, right? So 3, next one would be 4. 4 times 4 times 4, you might have to use a calculator for that. That's 64. So the cube root of 64 is 4, and so on. There's a few of these that you should know. This one, for instance, it says to use your calculator to evaluate, but I bet you we could do that. Since we got 3 zeros, do you see how it's going to be 10? The answer is going to be 10. But it asks us to use our calculator, so let's get some calculator action going. I have the graphing calculator here. Might be some junk left over. Yeah, a bunch of junk from an old lesson. On this one, I'm looking for my cube root button. And I got my square root button, but I don't have my cube root button. And I don't have it on a second function. Most scientific calculators will have it on second function, but I know it's under the math menu. And then there it is right there. So if I hit 4, it'll be the cube root of whatever I want. So the cube root of 1,000, and it should be 10. Otherwise, I don't know what I'm doing. Yeah, 10. on a scientific calculator, uh, these are the ones that you can't put stuff in the order that it appears. 1,000 has to go in first, and then this has a cube root button. You might have to press inverse or second function to get that cube root, but that's how you do it. And cube root of 1,000 is 10, so it's still 10. Now this one won't go evenly. This is the fifth root of 2012. On this calculator, well, I know I got to put whatever's underneath the root first into my calculator. Oops. And then somehow, zero button is not working here. 0, 1, 2. Somehow get it to do the fifth root. Notice there's no fifth root button. Well, this y root x or x root y on your calculator, it might be, is the anything root. So on these ones, these are like the old calculators, which are backwards. So if I hit that button and then 5, it'll give me the root. So this is about 4 point, what was that? 58. Okay? Most calculators aren't like they aren't like this one. They're not like this one. They're more like the graphing calculators. And you should be looking for this button, YX, or it might be X, root Y. It looks like this. This is the anything root. And on the graphing calculator, it looks like, oops, it looks like that one. That's it on the graphing calculator. But when you do it, you have to put which root you want first. It's almost like you can type it in like it reads. 5, and then that root button, however you'd hit it, and then 2012. And I should get the same answer unless I goof something up. No, it's the same answer, and that's approximate answer. What you should do, until you're used to this, until you remember, you should write your calculator steps down. Whichever calculator, if your calculator is more like this one, or your calculator is more like the graphing calculator, whichever calculator yours is more like, you should write down your calculator steps for that, because that's not easy, let alone when we start getting something goofy like this. All right, so the 7th root of blah, 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 blah. Okay, well, we'll have to figure out how to do that. I'm going to use the graphing calculator first. It's these calculators. Most people will have a calculator that looks like this, and we generally type it in exactly as it appears. So I want to put 7 and then hit my anything root button, which was right here. This is my anything root. It's kind of like the 7 takes the place of the x, and so it's going to be the 7th root of, and it's a big long expression underneath the bracket, so I want to put this in brackets. 2000 divided by 1.04, and that's my exponent button 5, end bracket equals. Okay, so that's about 2.88, and it's rounded, so I put in about equal to. There are the steps. That's another nice thing about these new calculators, is you can see what you've typed in, and so if you're having trouble, a neighbor or I can sort of check out where you made your error. On this one, on the older style scientific calculators, you have to hit that button 7 last. So that means I got to put the thing that's underneath the root in first. So I'm going to put that part in first. 2000 divided by 1.04 that's my to the exponent button 5, and I'm going to press equal. So that's this answer here. Now I want to do the 7th root. So I got to hit that button and then my 7th root button, and I should get the same thing. And yep, it is. Awesome. Be careful with your roots. The most of the rest of the lesson is an investigation. Now, in this video, I will take up the investigation. You will see my answers. Before you get too far into that, I want to mention something. So, like I said, there's a handout that should be in your package, and you go through this by yourself or with a partner. In class is fine, and then maybe come back to this to see the answers. this stuff I will take up in this video. The does this make sense parts I'll take up in the video, and I'll actually do a little bit of the homework as well. But I want you to goof around on your calculator a little bit first. One thing about this here, 2 to the exponent a half, the way you put that into your calculator is 2 to the exponent, or if you're using graphing calculator, it's that, to the exponent, and then you got to use brackets to do the half. 1 divided by 2 in brackets, and then press equals. And then you're going to get an answer there. The square root you should be able to do easy peasy. Okay? So over here, 2 to the exponent 1/3, 2 to the exponent bracket 1 divided by 3, and then you press equals. And why you would be doing that, who knows. The whole idea here, the whole goal, is to figure out what rational exponents, fractional exponents are about. That's the whole investigation. So you should pause the video. I'm going to do the same. So you can mess around with your calculator, see if you can see some patterns, and then come back again to take it up. Okay? Pause the video. No, I mean right now, pause the video and do this. Do it. Okay, great investigating. Good calculator work there, folks. You notice that they were the same, right? So what this meant is that when I have an exponent a half, that means to take the square root. And does that make sense? Well, yeah, I think it does, and here's why. For one thing, if I think about an expression, a to the exponent half, and if I multiply by a to the exponent half, well, that's 2 powers with the same base. I add the exponents, and I'm left with a half plus a half, right? That's a to the exponent 1, or just a. But think of it this way. I could think of it as, what's the square root of a times the square root of a? Well, that's just the square root of a squared. And if I were to square root something, then square it, I'm just going to get a back. So these things are the same. So that means these things are the same. A to the exponent half means square root. Similarly, and hopefully you found out the same thing, you're able to put into the exponent 1/3. You got something that looks something like that. And you concluded that 1/3 as an exponent is the same as the cube root. Does this make sense? Yes, I hope so, because of the exact same reason. Think of it. I got powers with the same base. All the exponents are 1/3. What do? I add the exponents. This is 1/3 plus 1/3 plus 1/3, which is just a to the exponent 1, which is just a. But if I think of it as the cube root of a, and the cube root of a, and the cube root of a, well, that's just something times itself 3 times. That's the cube root of a cubed, but these are opposite operations. You cube root something, then cube it, you're just going to get back the same thing that you started with. So since these are the same, these must be the same. A to the exponent 1/3 is the same as the cube root. And if we extend that idea, I got stuff here, that 1 over any root as a fraction must be the nth root. So fraction exponents mean roots. Who'd have thunk? Who'd have thunk? And these calculator exercises check that. Hopefully that checked out. The next part of the investigation, which I hope you've done, if you haven't done the next part of the investigation, this is part B I'm going to talk about next. It's that part right there. Don't look, don't look. Actually, I don't think I've written anything. So please try that. And if you haven't, pause the video, try it. It should only take about 5 minutes or so, maybe 10. And then I'll try and make sure you got out of it what you're supposed to get out of. Okay? Okay, so exploring the meaning of a to the exponent m over n. Notice that made a lot of sense. This made, you know, roots and fractional exponents made sense. But wasn't it convenient that that was a 1? Well, what happens when it's an m? And this investigation is supposed to show this. So you're supposed to pound a bunch of these things into your calculator. It ended up that those were always 1, but this is the one that they showed here. 4 to the exponent 3 halves ended up being 8. 4 to the exponent 5 halves, you know, it walks you through this. This is just that thing cubed. Look here, this is just this, you know, the square root, but then cubed. This was the square root, then cubed, right? Where we had 16. For this one, we put in 16 to the exponent 3 divided by 2, and we get 64. But this is the square root. So this is the square root cubed, and that's the pattern we were supposed to see. So how do you think the values of that will be related to values of a to the exponent 1/2? Well, I'll bet you what we need to do is take the square root first, whatever the square root is, and take that to the exponent 5. And what they were trying to explain in D was exponents on exponents. I multiply the exponents, fractional exponents. That's 5 over 2. So what I should do if I have a fraction like this is take the root first and then to the exponent 5. And hopefully you were correct in that. And so what about when it's 3 on the bottom? Well, it's the same thing, isn't it? This column is the cube root, just like we expected. This is a to the exponent 1/3 is the cube root. But then if the top is 2, it's just this squared, wasn't it? It was just the cube root then squared. It was the cube root squared. And this column is going to be the cube root to the exponent 5. Cube root to the exponent 5. And hopefully you notice that. How do you think a to the exponent m minus n is defined? Well, I'll bet you it's the nth root. Whatever the root is, the root goes on the bottom. The root goes on the bottom, and then we take it to the exponent m. That's the pattern you're supposed to see. This is the pattern that we'll practice tomorrow. This homework question is basically just practicing this. So here, I'm going to do a couple of these. 5a, 32 to the exponent 1/5. Well, the 5 is the root. This is the 5th root. And then what's the 5th root of 32? A number times itself 5 times. If you can do it without a calculator, it will be easy peasy. So the 5th root, well, this is just 2. And the exponent is 1. Done. If I try C, 16 to the exponent 3 halves. Well, I'm going to write it as a radical first, so write it as a root. I know the bottom is inside. Now what number goes here? The fraction part is the root, and the exponent is the top part is the exponent. So how do I calculate this? Well, I do the root first, and I can do this without a calculator. Square root of 16 is just 4, and to the exponent 3. Now, hopefully you can do 4 to the exponent 3 on your calculator. Or without a calculator, rather. 4 times 4 times 4 is 64. But if you can't, I suppose you could reach for a calculator at that point. These are the sorts of things that we'll practice also in tomorrow's lesson. So hopefully you got that pattern. This was the big scoop for today. This pattern right here. A to the exponent fraction is the nth root, and then I take the nth root and then I put it to the exponent m. And it allows us to solve problems like this, problems that we'll do again tomorrow. Okay, folks? Now, is there a little bit of homework? I think there's a little bit of homework, isn't there? Okay. Well, have fun with that. If you had trouble with this part, number 5, we're at this again tomorrow. So don't be afraid.